Welcome all. This course is speech and audio processing. So this is an introduction video, and in this course, this course is mainly designed for understanding the articulation, synthesis of human speech, and understanding different parameters of human speech. Then finding out different, you know, different features of the audio signal or speech signal using short time Fourier transform, and discussing the hidden Markov model, speech coding, speech verification, and different types of algorithms related to speech and audio processing will be taught in this course. So throughout this course, I will be following the books, the book by Rabiner S. Kaffer. The name of the book is Digital Processing of Speech Signal, and one more book is also there, you can refer it, that is Digital Speech Transmission, Enhancement, Coding and Error Concealment by Peter Vary and Rabiner Martin. And there are many useful websites. I have just written a few here, so you can follow these websites if you want to explore more on speech and audio signals. So in this course, I will not cover any soft computing or any algorithm related to deep learning. Rather, in this course, I will mainly cover the scientific aspects of the speech. That means how the speech production and perception is done by human beings, phonetics, different types of speech, that is voiced or unvoiced, acoustics, linguistics. These things will be covered very briefly, because this is mainly theoretical part. And then after that we will see different category of speech sounds, and we will try to locate these sounds in the acoustic waveforms. We will learn it, and we will also learn how the speech can be digitized, what kind of digital setup we should use to digitize the speech signal. Okay, so these things will also be covered. Then after that we will cover speech representation, that is in time domain as well as in frequency domain. So if you are going for frequency domain, then we will study spectrogram, and if we are considering the homomorphic domain, then there will be cepstrum analysis. So these things will be eventually covered. Apart from that, we will also cover linear predictive coding for speech signal, and then we will use, or we will study the hidden Markov model. After that, we will study few algorithm of speech coding, speech synthesis, speech or speaker recognition, and verification systems. So these things will be mainly covered in this course. And there are not only the this much applications in speech processing. There are many, such as text to speech conversion, language conversion, smart home application. There are many applications of this speech. If time permits, we will also cover those things. So before starting the introduction, let me briefly tell the course objectives. So from the learner's perspective, as a learner of this course of digital speech and audio processing, at the end of the whole syllabus, you should be able to develop a skill such that you will be able to know how speech is produced, how it is perceived. Then suppose a recorded signal is given to you, then suppose your name is recorded, then you should be able to visualize the recorded waveform in the computer, then using some softwares. Then you should be able to visualize the spectrogram, then level different speech signal points. So I expect that you should develop a practical skill along with the theory, such that given a speech signal you should be able to categorize and level the signal. Okay. Now let's start the introduction. So speech is the most natural form of human communication, as it is very evident. Then speech is also related to language. So linguistic is the science of language, which includes phonetics, phonology, morphology and syntax of the speech. Okay, so linguistic is the science related to it. Then speech is also related to human psychological capability. Speech is also related to sound. So acoustic is the branch of physics that deals with the study of mechanical waves in gases, liquids and solids, including topics such as vibration, sound, ultrasound and infrasound. So as we are dealing with speech, so it is like when you speak, it generates a waveform in the air. There will be a variation of pressure, air pressure. Okay, so it creates a waveform. So study of that is will come under acoustics. Okay, and yeah, then therefore speech is one of the most intriguing signal that human work in day-to-day life. Now what is the purpose of speech processing? Why do we need to study this syllabus? So this syllabus is designed to understand the speech as a means of communication, to represent speech for transmission and reproduction, to analyze speech for automatic recognition and extraction of information, and then to discover some psychological characteristics, some physiological characteristics of the talker. In general, in speech production as well as in many human engineered electronic communication systems, the information to be transmitted is encoded in the form of continuously varying waveform. It might be in analog or in digital. If you are working with digital signal, then here you need an analog to digital converter, okay, for converting the analog signal to digital one. Then after the conversion, the signal can be transmitted, it can be recorded, it can be manipulated. Manipulated means you can do any signal, you can apply any signal processing algorithm, okay, and then ultimately it is decoded by a human listener. Now as the name of the syllabus is speech and audio processing, let's have few facts of audio signal. So speech is also a kind of audio signal, okay. Then audio signal also includes music, some biomedical signals such as your heartbeat sound, respiratory sound. There are many more. And there is one more aspect of this audio signal, that is called synthetic audio or speech signal. So all these things will come under audio signal. Fine. So, we can say audio signals are the representation of sound which is in the form of digital and analog signals. Okay. Then the frequency of the sound range this is very known to everybody. This is the range is between 20 hertz to 20 kilohertz. Okay. So, actually this represents the lower and upper limit of our ears. Okay. Though 20 hertz and 20 kilohertz are the upper and lower limit, still the human auditory system is most sensitive between 500 hertz to 5 kilohertz. Now, however, we are not able to hear the sound, we are not able to hear the frequency, we are not able to hear a signal whose frequency is below 20 hertz, but still it can affect our ear as well as it can affect the different organs of the human body. Okay. Specifically, the infrasound whose frequency is of 7 hertz that affects the organ of our body. It may disturb the heart and brain activity because this frequency is very close to the characteristic frequency of these organs. Okay. So, audio signal processing is a method where we will study intensive algorithms and techniques that are applied to audio signals. So, we will also try to cover this in this course. Now, coming to different application of digital speech processing. So, here I have noted down few applications. It is you will find the application of speech processing in digital transmission and storage. Apart from that, you will find the application in speech synthesis. So, generally digital transmission is done. So when you talk over phone, your speech signal is transmitted from one point to another, and apart from that you need to store the signal, audio signal. Suppose it can be a song or it can be a voice, so you need to store it. So for that you need to encode your signal, so that will come under this. Then speech synthesis, so its application you will find in many places. So one of the example is your Alexa, or different smart home appliances. Then apart from that, suppose any we can say it like suppose you are going to a ticket counter, and where you need a ticket, so you can just speak it. So, I need a ticket from this place to this place. Okay. So, that is recognized by a system, and then a ticket is generated and it is given to you. Okay. So, that will also come here. So, some speech synthesis part is implemented in the device. Then apart from that, you will find the application in speech recognition, speaker recognition, verification and identification. Then the question arises, what is the difference between speech recognition and speaker recognition? So, in speech recognition, we try to recognize the words that is spoken, okay, or what is spoken. Okay. Then in speaker recognition, we are more concerned on who spoke it. Okay. So, this is the main difference between speech recognition and speaker recognition, and apart from that you will find the application in verification as well as in identification, because the speech of each human being has its own signature. So, that can be used for verification as well as for identification. Then apart from that, you will study many algorithms, or you will find many algorithms which is used to enhance the speech quality, and you will also find the application in different aids, I mean in developing different aids for visually challenged people or mentally challenged people. So, you will find the application there also. And apart, I mean this is just few applications. You will find numerous application in day to day world. I mean to name even more few more applications like word spotting. So, you will spot a particular word in a sentence, and after spotting that word you can categorize the particular, I mean you can categorize a given statement or given sentence in, I mean you can categorize it. Okay. Then after that, I mean it is used in language translation. So, language translation, again you can translate from one language to another language, and apart from that, even suppose we will consider English language. So, generally what happens, suppose one American, I mean speaks in English, and then an Indian speaks the same English, same sentence suppose, and then suppose a Spanish person also speaks the same sentence. So, you will be able to distinguish between the different accents of the same English sentence. Okay. So, there are many applications or there are many algorithms that has been developed to convert the American English to Indian English or Indian English to American English. So, that thing I mean that work has already been done, and people are now, even people are working on it. So, this will come under speech prosody. Okay. Then apart from that, you will find the application in biomedical sector. So, to detect any diseases from heart sound or from respiratory sound. So, that work, I mean there is also, I mean you will file the application in biomedical sector, and there are many more. I mean these are just to name a few. Now, we will briefly discuss few of the applications. So, the first one is speech coding. So, it is the most widespread application of digital speech processing technique, and you will find this speech coding is mainly used for digital transmission and storage. And the goal of speech coding is to compress the speech signal without losing any important detail. So, this is the block diagram of speech coding. So, here the speech signal is there in analog form, which is converted to digital form by analog to digital converter, and then the second block is analysis or encoding block. So, here we will find the application of different algorithms. Algos for coding the signal. Then after coding you will find find something which is represented by yn. So, here I cannot say yn is my speech signal, okay, because it has already been encoded. Okay, without decoding you will not get back your speech signal or audio signal. So, this signal we can call it as a data signal. Okay, this is no more a speech signal or audio signal. And after that, this encoded signal is transmitted through the channel or any given medium, then at the receiver side the same data, the data is received, and it is expected that yn and y cap n, that means at the sender part and at the receiver part, it should be almost identical to each other. Okay, if they are not identical, then definitely you are going to lose some information. Then after receiving this y cap n, you cannot directly listen it. So first you need to decode it or you need to synthesize it. Okay, then you will get the signal in digital format. After that, you need to convert this digital signal into analog format such that the humans will be able to hear it or decode it. And this speech coding algorithms should be very carefully designed such that the transmission, here this entire portion should be this should be designed very carefully such that this xn and x cap n are essentially identical to each other. Okay. And then the next application is text to speech synthesis. In short, it is very popularly known as TTS, that is text to speech synthesis. So this whole process, it starts with a text, and then at the output the speech is produced automatically. Okay, the algorithm is designed in such a way. The input can be a ordinary text, can be a text from the book, it can be an email message, or it can be an article from the newspaper. Okay. So in the first block, that is your linguistic block, so here it converts the printed text into set of sounds that a machine must synthesize. Okay. So it involves few linguistic rules that determines the appropriate set of sounds. So here it will include like where to give emphasis, or where to pause, or the rate of speaking, whether you should speak fast or you should speak slowly. So that is determined here. And then the difference between pronunciation of similar type of words. So this all things are determined by the linguistic rules. Okay. So these rules are generated such that the resulting synthetic speech will express the words as well as the intent of the text message in such a manner that can be decoded easily by a human ear and brain. Okay. Now the second block is synthesis algorithm. So here the role of the synthesis algorithm is to simulate the action of the vocal tract system in creating the sounds of the speech. Okay. Then after that, the output will be in digital format, then you need to convert it into analog format to listen it. Okay. So again this is a very essential component of human machine communication. Such as different smart home devices. Okay. Then the next kind of application is speech recognition. So it is another large class of digital speech processing application which is concerned with automatic extraction of information from a speech signal. So once you generate the features from a speech signal, then after that it can be used, after this block, the features can be used for speech recognition, or it can be used for speaker recognition, or it can be used for word spotting. Many, these are the pattern recognition application. Okay. So, here the first block converts the analog signal into digital signal, then some algorithms are followed to find out the features related to a given speech signal, and once the features are generated, then the pattern matching is done to perform a particular task, as I have already told. So, these are the few applications. We will study all the algorithms in detail as we proceed in this course. Okay. So, as a course at the end of the course, I expect that you will be having a qualitative description of the mechanism of speech production and speech perception. Then you will be able to analyze the speech or audio signal both in time and frequency domains. You will be able to categorize and label different speech sound of a given speech signal based on the spectrographic view and the time domain view. Apart from that, you will be able to understand the process of quantization and coding of speech or audio signals. Then we will solve problems regarding the parameter estimation for audio analysis and synthesis using different models. Then at the end of the course, we will implement few simple pattern recognition application of speech processing, such as speaker and speech recognition, and solve such that you will be able to solve any given problems using the audio signal. So, thank you.